In my previous demos, you've probably seen me use MOLT fetch and verify as part of Postgres, MySQL, and Oracle migrations to CockroachDB. In this demo, I'll be showing you the complete migration lifecycle, right from the database all the way up to the application. Today we'll focus on Oracle, but the same would hold true for any database. Let's get started. The first thing I'll do is build a copy of the MOLT tool and the replicator tool. This will involve changing to the MOLT directory, pulling the code, building it such that it supports an Oracle migration, and replacing anything that I have in my path with the new binary. I'll do the same for the replicator. And I'll come out of there. And now that I have the MOLT and replicator binaries installed, I can get going. You'll probably find by the time this video releases that there's a pre-built version of MOLT and replicator that you can use against Oracle directly. The first thing I'll do is start Oracle and then monitor the logs. Now this takes up to about 5 minutes to start, so I'll disappear, let this finish, and I'll see you in a minute. Right, that's just finished. That took about 7 minutes to come up. So now I'll create the database schema, and that looks like this. I create a bank service user. I grant a bunch of permissions to it. You'll probably want to limit the permissions that you set, but this is just for my local demo. I create a sequence and a customer. I know you can use identities, but this is the way that I'm familiar with. And I create a customer table that has a name and email address that is concerned with things like the name and the email address of a customer, a before update trigger that sets the updated at timestamp, an account table with a sequence again. This table is concerned with the customer's account balance and a trigger for that. I have a helper procedure to open an account, and I just take the details of the customer and their initial balance. Next, I have a procedure to make a transfer. It takes 3 parameters: the ID of the account to transfer the balance from, the ID of the account to transfer the balance to, and the amount we're transferring. Finally, I have a bit of code that just simply inserts 1,000 customers. So let's run that. That's my schema created and my data inserted. And now I can run my API. So the API is simply an application that has endpoints exposed. And I have 2 implementations of the data side of things: an Oracle repo, which handles my connection to the Oracle database, and a nearly identical repo to handle my Postgres connection. Now, obviously you won't have the Postgres version if you're just running against Oracle, but as part of your migration process, you'll want to tailor your application so that it can talk to your migration target. In my server, I set up a bunch of endpoints: 1 to open an account, 1 to return customers, 1 to return a specific customer, 1 to fetch a customer's account balance, and finally a post endpoint to make a transfer, all exposed via a parent path of API. I'll start that, and then I'll run a very simple workload against it. This is just a little application that I wrote that can talk to APIs. And all I'm doing is making transfers and fetching the account balance. So every time this ticks, you'll see it increment by 2. So this is our working business now. And at this point, let's say we're a few years down the line and we decide to migrate to CockroachDB. I'll start CockroachDB in Docker as well, and I'll create the objects, and they look like this. I'll have a database called bank. I'll create my customer table and my account table. Notice that the IDs are integers in this case. This is to make for an easier migration from Oracle to CockroachDB, but naturally you'd probably want to use UUIDs for CockroachDB IDs. I have a function to open an account and a procedure to make a transfer in the same way that I do for Oracle. You might want to lift this functionality out of the database and into the application, but just to make for a like-for-like comparison, I've chosen to re-implement them in CockroachDB. I'll create that schema. And this is the point at which we're ready to start the migration. So let's give ourselves a bit more space. I'll hop onto the Oracle container and log in as sysdba. And next I need to enable a few things. First of all, I need to change the log mode from no archive log to archive log. And you'll see that unless your database is already running as archive log, this might involve a little bit of downtime while the database comes back up again. So the database is coming back up now, and it will start as archive log. Now we're back up online and the application's happy again. Next, I'll enable supplemental primary key logging. And I'll create a user to perform my Oracle to CockroachDB migration. Note that this is a common user, hence the C ##. Next, I'll grant a bunch of permissions to that user. I'll switch to the default DB container and I'll grant some more permissions. I'll create a replicator sentinel table. This will be used by replicator during the replication period. I'll grant access to the migration user on that. Some more permissions. And this is the point where I start to enable log miner. Now, log miner is what replicator uses to replicate data from Oracle and into CockroachDB. So now you'll see me doing a bunch of things with log miner. I'll hop back into the CDB container, grant a bunch more permissions. You might not need to grant all of these permissions, but during the course of the trial and error it took me to get this working, I had to grant a bunch. And now let's go back to the default DB, get this current SCN or system change number, and start log miner passing that start system change number. Now we're ready to migrate. First of all, I'll connect to CockroachDB. Notice that I connect to my bank database. And if I select everything from the account table, you'll notice that I don't have any data at the moment. Let's just give ourselves a bit more space here. And now the migration actually begins. I have a copy of the Oracle Instant Client on my machine. The first thing I need to do is export two environment variables which point to my Instant Client. Next, I'll run MOLT fetch to do a big fetch of all of the data in Oracle into CockroachDB. This doesn't require any downtime, but it does make sure that all of the data in Oracle is available in CockroachDB up to a specific point. My source database is Oracle. Note that I'm connecting via the common user, and the source CDB is the same, albeit a different schema. My target is CockroachDB. I'm loading data, filtering on the schema. So this is my Oracle bank schema. I'm doing a direct copy, although you can stage it into files or S3 wherever you like. Probably better for production workloads. Because my CockroachDB instance isn't using any password authentication because it's all local, I allow disabled TLS. I'm not using any compression. My local data path is data MOLT, and I output just a standard out. I don't want to create an additional log file. With that running, if I rerun my select count, so that's finished now. With that, I'll be able to check on the count, and now I have the 1001 rows that exist in the Oracle database. I'm still making changes to the Oracle data, so CockroachDB isn't entirely up to date, but if there's a bunch of historical data that you have, that's all there in CockroachDB now. The only thing we need to do now is make those incremental changes from this point. Now this returns two important values, the backfill from system change number, which I'll capture, and the system change number. This will tell replicator that we've replicated data up to this point in time. So that's the backfill from system change number and the system change number. And this will tell the replicator binary everything it's missed since we did that MOLT fetch. And because of our onUpdate trigger, in Oracle, we'll be changing the updated at column value. And because replicator is streaming changes from Oracle now, that value will be increasing. So 1131.42, 1131.45. So the data is constantly streaming into CockroachDB, and the application is still live and talking to Oracle. Now at this point, you've got a decision to make. If you want a consistent cutover, you'll probably need a bit of downtime. Now, that's not to say that zero downtime migrations are impossible. They're just a bit more involved. For simplicity's sake, I'm going to stop my application now to allow the data in CockroachDB to completely catch up with the data in Oracle. So I'll stop my application workload and I'll stop the API. You'll see that replicator has noticed that there's no more data to copy over. And this is the start of our cutover period. Now, I'm talking through this, so this is slower than it would be in your case, but I can now run MOLT verify. I'll stop replicator because there's no more data coming through, and I'll run MOLT verify. That's finished. It saw 1001 rows, of which 1001 are identical in CockroachDB. So we're now in a good position to switch over to CockroachDB. It's at this point you'll want to make the switch in your application to point to CockroachDB, or maybe flick your load balancer from Oracle to CockroachDB. The choice is yours. But before I do, again, just to maintain consistency with Oracle, I'll create a few trigger function pairs. And this will simply ensure that my updated at column is updated when I make changes. So that was one for the customer table, one for the account table, and then the before insert or update trigger counterparts. It's a new day, it's a new me, it's a new band t-shirt, but we're at the point where we left off with our 1001 matching rows in Oracle and CockroachDB. This is still part of the downtime. Now, before I can start my workload, I'll capture the logical timestamp in CockroachDB, and that will be used in a minute. I can now start my API, this time talking to CockroachDB. I'll start my workload, and this time requests are being made against CockroachDB. I can look at the last updated time, and you'll see that the last update is going to tick up every time I run this command. That's our migration complete. We've migrated from Oracle to CockroachDB, and our application and workload are now talking to CockroachDB. If for any reason you want to migrate back from CockroachDB to Oracle, we've made that very easy. MOLT Replicator allows you to replicate data from CockroachDB to any of the source databases that you may have previously migrated from, including Oracle. So to show you how easy that is, I'll now replicate the data live from CockroachDB back to Oracle to show you what that might look like. The first thing I want to do in Oracle is to disable the updated at triggers. This is to ensure that I use the updated at value from CockroachDB and don't try to update it again when I replicate data from Cockroach to Oracle. I'll grant the common user insert, update and delete access against the customer and account tables. And then I'll configure CockroachDB. So Replicator will use CockroachDB's built-in CDC to pump transactionally consistent changes from Cockroach into Oracle or any of your previous source databases. I'll enable range feeds and I'll alter a few cluster settings to optimize for replication. You might want to tailor these settings to your workload. Next, I'll create the change feed itself. And what we're doing here is we're simply creating a webhook change feed for both the customer and the account tables. Because CockroachDB is running in a Docker container, I'll target my replicator that's running outside of Docker on my host. I'll use the timestamp that I created earlier. I won't do an initial scan. I'll only do changes since that cursor value. And I'll make sure that I flush either when this number of bytes are added or updated in the table or 1 second has elapsed. Now, if there's a replicator database already on the instance, which there will be from my previous replication to CockroachDB, I'll drop that now and re-enable SQL Safe Updates. And then all that's left to do is to start Replicator. This time, my staging connection is my current CockroachDB database. In production workloads, you might want to use a separate instance of CockroachDB to act as your staging environment. Note that your source database will still be the one that's pumping messages out of CDC. And my target connection is now Oracle. So currently, our last updated time is quite a bit further back in Oracle. But with Replicator running, once that gets started, CockroachDB data will start to come through into Oracle. Data's coming through, and if I run that request again, you'll see that we've jumped up and data is now up to date in Oracle. We can compare that against CockroachDB, and Oracle is following CockroachDB. If I stop my workload, allow those timestamps to synchronize, which they have, both values are the same. I can stop Replicator now and run MOLT verify one last time. This time, my source database is CockroachDB and my target database is Oracle. That's finished, and we've seen 1002 rows. I started my workload again, which created a brand new user, which explains the additional row, all of which are identical in Oracle. So our Failback migration has finished. We could point our workload at this point back to Oracle if we wished. So that was a complete migration from the database all the way through up to and including the application from Oracle to CockroachDB. As I say, you can run this process for any database that MOLT supports, both to CockroachDB and if for any reason you need to, back from CockroachDB.